Hello, I am Shreyas from India and a recent motorsport graduate from Oxford University. I am an ardent motorsport and cricket lover. So when I was growing up, I had seen pedal shift or whether be it blown diffusers or some of the wonderful inventions regarding aerodynamics and all these stuff. I just always used to wonder how one would come up with these things, and if I were to come up with this thing, how I would go about my business. What would the process be, instead of what the end result is. Now that's also my little segue into the next part of the video, which is my motivation for applying into the program. So Formula One has, as I already mentioned, has seen a huge chunk of innovation, and a major part of those has made or seen its way into the commercial part of the automobile. Now, but because of the way Formula One is made, constructors who already have huge factories or huge number of sales enter into these competition to conduct R&D and spend millions of dollars, and so those research are not useless entirely. They just put it into their commercial vehicles and kind of sell it, and so that's perfect for Formula One when it comes to innovation in the automotive sector. But what really happens when you try and do innovations in the academic field or in the industrial scene is quite different, because there's a huge bridge, there's a huge gap, and I think that's where my area of interest lies in. And so my work experience, my education, which we'll discuss later in the video, also kind of molds into that little area, little section. Now coming to my experience and education, and how that has luckily or fortunately, I would say rather, been in sync with what I'm trying to do here. I did my bachelor's in automotive engineering. Then I later did my post-graduation from Oxford University in motorsport engineering, citing my motivation in the Formula One industry. Now coming to my experience, that has also fortunately been in sync with the program with the PDEng program. After completing my master's in motorsport engineering, I joined one of the startups, and from contributing in a startup and dealing with industry-led real life problems from real consumers, I felt that there is this huge gap. I always knew there was this huge gap, but when I went into the industry, I felt that there was this huge gap between what we are taught. This was completely different to what a PhD student might have tried to do. In my current role at Coixlon, which I very recently joined, and it's a service-based company, so it's not a startup which is product-based company. It's a service-based company which offers automobile solutions or FEA simulations, or rather any kind of ranging from 1D simulation to CAD mockup, build-up, n number of services. Now moving on to the next section, wherein I'd like to discuss a bit of my work from previous work experience and education, and I'd also like to discuss a bit about some of the other topics that I might not be able to cover, just a gist of it. So the couple of topics that I'll be covering is vehicle dynamics and powertrains. But when I say vehicle dynamics so when I was doing my master's in motorsport engineering, I was part of this wonderful team, the Oxford Brookes Autonomous Racing team. And so therein I was part of the testing team, and how we could test our hardware. And so my master's thesis also aligned with the same research, and I made and developed a model predictive controller, or an MPC controller, for the autonomous electric vehicle, and I was also part of the electric vehicle as the powertrain lead. So I know I knew the vehicle inside out, but what I dealt with was mostly vehicle dynamics as to how the vehicle would perform, how much the vehicle would yaw, how much the vehicle would roll, what would the pitch be, what would the tire grip be if we go beyond this speed limit, velocity limit, grip limit, what would happen. So all those things, coming from a vehicle dynamics perspective, put together in an autonomous vehicle in the form of an MPC controller was studied. I also developed a lateral Stanley controller, but that did not, but because a lot of external factors like time and it didn't align with what we were really trying to do. It didn't meet the objectives of what I was really trying to do, and so that just kind of stopped or paused at the model phase, and I couldn't continue that. Both of this work can be, so my MPC controller is a published paper in SAE, and all of these reports, the detailed reports of hardware and everything, is not published but can be found in my website on my GitHub page, which you can find on my CV or on the description below. Now coming to the powertrain sector, back in my undergraduate days, I was part of this team called Shalico Marathon, where we would try and get maximum fuel efficiency from an IC engine. We were participating in the IC sector. And so when I say powertrain, it's not just IC, but I'll start with the IC and move into electric. First year, I was involved in the conversion of carbureted 110cc CVT engine into an electronic fuel injected engine. And so therein it involved a little bit of engine tuning, a little bit of learning electronics and sensors and throttle efficiency and stuff like that. And moving on to the second year, I developed a wheel hub which was specific to our CVT model. So these were two prominent projects, but there were other projects, and in my final year I was leading the team. I moved into my master's. I really wanted to move on from the ICE sector and do something in the electric powertrain sector, and I've briefed this in the earlier part of the video, wherein I said I was electric powertrain lead on the Oxford Brookes racing team. And so I was in charge of so we had 4 hub motors on the 4 wheels, and I was in charge of the epicyclic gearboxes. We had epicyclic gearboxes on all 4 wheels, and hub motors, wheel hub motors on all 4 wheels. So I was also leading the traction team and the BMS and the electronic power systems team rather. I've worked with powertrains of different kinds. I've worked with transmission, that means drivetrains of different kinds. And when I say vehicle dynamics, I've not just worked in vehicle dynamics, I've worked with vehicle dynamics and autonomous. And so that's also touching into the third topic, which is ADAS a little bit. And so I've enjoyed thoroughly working on all this. Now what that has done is given me a cross-functionality knowledge of different domains. So when I'm designing, when I'm focusing on a particular knowledge of a particular sector or a particular segment or a particular subsystem in a vehicle, I can really understand what the other subsystems and other subteams want, and that can really enhance my design of this subsystem, because at the end of the day, all these systems just collaborate and make it a one vehicle, and we are making one product, not one subsystem. So that's my reasoning or explanation of why I have ventured into different projects, different areas at different points of time. All of these reports, as I've mentioned previously, can be found in my GitHub page. So I think I'd like to conclude with all of this information. I think I'll make a perfect fit. I think the university would also, or rather the program would also benefit from having me with different functionality knowledge. I think that's my sign off. Thank you. Goodbye.